Okay, we are going to look at a one-dimensional motion problem with constant acceleration. Go through that process and solve it through the method that we want to for our course. You're driving a car at 15 meters per second when you see a red light up ahead. You let off the gas and let your car coast, slowing down naturally. After 15 seconds, the light turns green. You're going 5 meters per second at this point, so you hit the gas. How far did you travel while the car was coasting? All right, so the first step in our problem-solving process is to define what are we interested in. What is our time base that we care about in this story that we're analyzing? And we care about when we first see that light up ahead and then when it turns green again. So we're interested in how far we travel during that time blank. So our initial condition is when we see the light. Now, there's other ways to describe that. Perhaps it's when you take your foot off the gas or when you begin to slow down. So any of those conceptual ideas describe the problem just fine, but we want to make sure we understand when we care about the motion. All right, when do we stop caring? Well, when that light turns green. This also could be described as when we hit the gas or when we start to speed up again. So it's okay if you use different ways to describe it. We just want to make sure we are defining when that motion is taking place to guide us through that problem-solving process. All right, next thing we do is define our world, and we do that by drawing a picture. So there's my car, there's my light up ahead, and I'm going to say that the position 0, my origin, is when the car is at the location the car is at when it sees that red light up ahead. Okay, so what is our descriptors for this motion? Remember, those are initial and final position, initial and final velocity, acceleration, and time. And those initial and finals relate to those timestamps that we've defined about the problem. So where am I when I see that light turn red, or when I see the light is red? Well, I defined my position at that point as the origin. So we are going to define my initial position. I'm at the origin that I chose. Where am I when it turns green? I don't know. Didn't give me that information in the problem, so we'll put that as a question mark. How fast am I going when I see that light up ahead? Well, it says I'm going 15 meters per second, and when I see it turn green, I'm going 5 meters per second. I'm not given what the acceleration of my coasting is, but I am told I do it for 15 seconds. So my time is 15 seconds. All right. We're interested in knowing how far we coast. Well, that's a displacement, that how far question. And so we need initial and final positions. That displacement will be given by our final position in this problem. Okay, so what equation do I use? I have those tools in my toolbox. I have final position, I have initial velocity, and I have time. I don't have acceleration, and I don't have final position. All right, so I know that x final is equal to x initial plus v initial t plus 1/2 at squared. This is one of the most powerful equations to use, so I like to start there if I'm a little unsure. X final, well, I don't know what that is, so we'll keep that as its variable. X initial, well, that's 0. V initial is 15. The time is 15. Plus 1/2, oh, I don't know my acceleration, times 15 squared. So in order to answer this equation, I need acceleration. All right, well, that makes acceleration a variable of interest. So, well, I have initial, final velocity, and time, and I know those are related through the equation v final is equal to v initial plus acceleration times time. So v final is 5. V initial is 15. I don't know my acceleration, but I know my time, of course, is 15. So I can solve for acceleration. I have minus 10 is equal to 15 times my acceleration. So my acceleration is negative 0.67 meters per second squared. So 10 divided by 15. Now I can use that in my relationship up here. So I have x final is equal to 15 times 15. I should probably know that, but let's just make it explicit. What, 225 I think is 15 squared? We should always be doing our mental math so we don't lose it. Yes, 225 equals 225 plus 1/2 negative 0.67 times 225. All right, so we have 225 times 0.5 times 0.67. We get 225 minus 75.375, and our position is 149.625, but if we use our significant figures, 150 meters. And since our final position is relative, or our displacement, excuse me, is relative to our initial position, and our initial position is 0, x final gives us the distance we coast. All right, so following that process, defining what we are interested in that time bank, defining our world, setting that origin, making our list of descriptors, and using that information to get at what we want. Good job.